Hello everyone, this is Group 1's interim project presentation for ME452 Spring 2025, the redesign for the cordless handheld vacuum cleaner. The selected product is compact, cordless, and powered by a rechargeable battery that can be recharged in under 3 hours. Weighing under 1 kilogram, it's small enough for easy storage. Annual estimated demand and production value are 150 million and 50 million respectively. Primary customers are everyday consumers seeking quick cordless cleanup for small messes. Secondary customers include auto details and rideshare drivers who need strong suction and portable convenience for frequent vehicle cleaning.
So our fast diagram follows the normal convention, and the vacuum is actually very simple, where the task function only has a few primary basic functions to cover what it does in the Y category without limiting creativity and design. And the same applies to the basic supporting functions, and it still sticks to the how Y while retaining flexibility.
So here for our handless vacuum cleaner, we have two different assembly sequences. In sequence 1, in the first line we build the rear housing. In the second line we build the motor first and then the front suction, and then join those two assembly lines for final assembly. And then in sequence 2, we have two different sub-assemblies, one for power on the left and dust on the right. We then join those together, add some final parts for final assembly. And then in comparing these sequences, we find that sequence 2 has a higher score of 14 compared to 9, and that's because the sub-assemblies generally are easier to manage and they can be tested independently. And then here we have our function component mapping matrix, which shows us for each of our 15 different parts how each of them fulfills the requirements that we have for our design.
This exploded view shows the key parts of our handheld vacuum. At the front are the silicone nozzle, semi-transparent shell, and dirt cup, followed by a filter. The fan connects to the motor, which is secured inside the motor housing. The rear section features handle with power switch, battery, exhaust vent, and charging point, all designed for portability and ease of use. The bill of materials lists each component, its material and production cost. Most plastic parts are injection molded. CNC machining is used for precise parts like the lock pin and charging point. The battery and motor are the most costly items since those are the off-the-shelf product. And the total cost per unit is around $22.24.
So the vacuum is fairly well designed in that most of the components fall within the optimal category, where they can stay as is. But from a pure manufacturing perspective, some of the features could be eliminated because they're outweighed by the savings, just like having the transparent plastic, where it would be a nice feature, yeah, but we could do better. And there are a handful of ways to work around the components that need redesign, so look forward to that final presentation.
In this section, I'm showing how we translated customer needs into our product architecture. In the column on the left of the functional differentiation table are essential functions everyone expects: lifting surface debris, holding it, basic filtering, portability, recharging, comfortable handling, and easy emptying. These are all the must-haves. And on the right, for our professional users, we're really boosting the vacuum's capability. This means significantly more cleaning power for tougher jobs, enhanced filtering with the HEPA filter, and the ability to work longer and handle more debris without interruption. Essentially, it's built to meet demanding professional standards. Looking at our component commonality table, it shows how we build this efficiently. The platform components on the left, like the housing interlock, lock pin, power switch, handle, motor housing, and charging point, are shared across both versions. This common base streamlines manufacturing and reduces manufacturing costs. The modules on the right are our key differentiators. By swapping out the motor, fan, dirt cup, filter, and silicone nozzle, we tailor each vacuum. This modularity allows us to offer a high-performance professional variant and a cost-effective household model, all from one smart design foundation.
From our product family design, first module change is the dirt cup and nozzle. Small dirt cup and nozzle for our primary consumers, and our larger dirt cup and nozzle are for our secondary consumers for greater cleaning capabilities and dirt storage. Common interface for this module is the lock pin that allows the dirt cup to snap on and off. Here are the motor and fan variants with our variant 1 on the left-hand side for primary consumers and variant 2 for secondary consumers, more powerful and upgraded filtration. A common interface for the motor battery housing.
Now we're going to talk about the assembly sequence analysis part of the product family design. We start off with our versatile handle with the power switch, and then we switch to our motor housing, Then we attach our two different motors and the two different fans, two different filters, two different dirt cups, and then the same lock pin, the same housing interlock head, and our two different silicone nozzles. Now, the only problem with their original assembly sequence is that it's not the most optimized. Now, the way we're going to optimize this is by having something called delayed differentiation. Now, what this is that we take our only different components of each design for both our primary and our secondary customer groups, and we delay this differentiation in the assembly sequence to not only save more time and money, but to reduce the complexity of our assembly process. Now, the only modifications between the original and the modified is just the order of the motor, the fan filter, and the dirt cup, with the silicone nozzle staying in the same exact place. Now, instead, we have the lock pin and the housing being assembled before these different components, now achieving our delayed differentiation.